Intel, based in Swindon. They asked us to come down, the team over there, got Paul and Kieran over there. Just to talk to you a bit more about what's happening at Intel, what we're bringing out this year. You see so many adverts around the place, and all looks very much like what another one sort of thing, have either a difference. So I'm going to try and just guide you through what's bringing out this year, why it's exciting, what use it could be to you, and just basically give you an education as to what you can look for next time you go and buy some more computers or something. So, what I'll do, there's a few speakers here, so that's the legal display which I was actually on later. Video here, so this video I'm going to show you, just give you kind of a marketing spiel to what the latest and greatest Intel processors are. Sound in the background, there's a commentary, so hopefully this will work. Just see it. It goes to the line screen, so bear with me. So that's pretty much what's happening in place of nice marketing perspective in the world. Is anybody here who technical at all? Do you figure out IT at all? Not personal background. So what I'll do is just give it over a nice high-level discussion as to what it's all about, what you can see in places like PC World or the online retailers this year. So, who's heard of the Intel Core processors? Good, so it's getting some of you. So every year, Intel tends to bring out the next generation of technology with a cadence. We will invest in new technology, we will put it onto the next greater silicon, which makes it more power efficient, and we bring out a more capable device, which then has a big headroom to do it a lot more, much quicker. And then the software guys put a lot more software into it to make sure it's more functional and it slows it all down. We bring the next one. So over the last few years, we've had basically the first generation about 4 years ago, Core i5. It's still called Intel Core i3, i5, i7. We've changed the logos a couple of times. The first generation was smart performance. And what that means is basically rather than just have a thing, an engine running at full power all the time, it looked at what the workload was and it decided to adjust its power consumption accordingly. So it's not running at full stop all the time, it's only just doing something like web browsing. Next slide, the next generation, the second generation, we bought some visually smart ones, which basically added a lot more technology to the graphics side of it and made the graphics more functional. So say you have to buy a discrete graphics card or plug-in graphics card to build the technology, better technology actually into the processor itself. So it saves you costs, it saves you power consumption, it saves basically a lot of things which benefits the end user. The last year's generation, Copenhagen Sandy Bridge, third generation, we added the enhanced capabilities of our graphics, so a bit more, and it's more credible. And this year, 2 months ago in June, we brought out the fourth generation Core processor, which is this year's iteration basically. It's a major evolution, it's a major move in some of the technology we've built into it, so it's a big jump from last year's technology. I'll try to explain some of those at a high level now. So we basically there's three main areas. Next slide. But it's the technology brought into that it's a very, very small silicon size. It's very, very capable, so you can do a lot more with the same device, even from last year's technology to this year's technology at a very similar cost. So you buy last year's laptop and compare this year's laptop. This can do much more. Once it's doing much more, much quicker, it also reduces the power consumption of it, so you can do it for longer. So you can do more computing all day. It says here 9 hours battery life, so that's useful battery life. You can get an Ultrabook or an Acer or Lenovo or somebody else's laptop, and you can work on that device for up to 9 hours roughly. So you go on a plane, go to transatlantic, or you go on trains there and back. You can still use that device when you come back and watch videos and things like that. So also the range of products which enable you to go from the full power old-fashioned, should I say, laptops and big clunky things, down to the smallest tablet now. We've got a range of scaling range of products that fit from the high size down to the very low 2-watt power threads. So realistically, we've been designing a whole range of products and making the end users choose from their suppliers. The suppliers choose from us, which they want to put into it. At the end of the day, it fits every single thing from the smallest atom-based tablet to the biggest desktops. There's no desktops on there, it doesn't still desktops. So we covered some of the notable form factors, some of the device form factors here, mentioned tablets. The technology allows the people who make these things called OEMs and ODMs to actually build new technologies into their designs. So this one here, about 3 years old, it's heavy, it's clunky, if I crack the back, that's something heavy. I'm due for replacement this year, which is good. You can get these things called detachable tablets. So, I've got my phone here. It's paperback, so I have to try and read emails on the iPhone to respond to bad fingers and bad eyesight. It's much easier to do on a tablet, so a 10-inch size tablet where I can flash it quickly. And then if I really wanted to do a serious Word or a long document, I really want to have a keyboard rather than touch. So the beauty of convertibles and the detachables here is you get best of both worlds. Detachables basically have a tablet which you attach a keyboard to. And that enables you, if you just go into an event like this, for example, you can still keep your contact with your home and not have to pick the keyboard with you. And then you get back home, or you get back to your company, and you can then add a keyboard to it, so you can do some serious typing. It's best of both worlds. Ultrabook, hopefully you've heard some of the adverts out there that says inspired by Intel. Ultrabook really is, we have one on the back there, but it's not exactly the best model. It's a very early demonstration. What the colleague's holding up there. It looks like a laptop. In fact, it is really a very thin, high-performance laptop, but it's got excellent graphics in it. It does everything that you need it to do, and other things. It's got things like sensors in it, so you can detect temperatures, it knows where you are. It's like an iPhone, but it's in the modern-day form factor. Convertibles, on the form along the left there, that is basically a Dell XPS. So you can use it as a tablet that folds like that, and you just have a tablet thing. And you look it up, the screen is found 80 degrees, and you have, of course, a full conventional laptop. Technology stuff, people like Dell, Lenovo, and Acer, those guys build these things. You mentioned notebooks, desktops. So this is probably, how many of you guys still use desktops back in your companies? Okay. So they're kind of very functional, they do what they need to do. Sometimes these days, especially like one of my study room at home, I put that on to do some stuff like Windows MP3s and my holiday next week, and after about 20 minutes, if the phone's whirring away like mad, it heats the whole room, it's hot up there in the first place. So it does what it's supposed to do, but things move on, and we make sure that we have technologies there to help people create new versions. So thin clients, app-based systems, but most of the work is done on the server. Desktop traditional, most of you guys have got already. And all in ones, we've got one back there, which is basically, it looks like a monitor, but it's got the actual computing built into the back of it, so you don't have a separate box. Everything's built into the back of the monitor. Space saver if you run on the wall, you use wireless keyboards, so it's a whole bunch of things. Moving forward. So what is the fourth generation bringing out this year? Three main things. Performance, I mentioned. We can do a lot more. We can do a lot more with a lot less power. Visuals, we've got a whole range of much better visuals this year. So visuals means graphics performance. You can see it, it's crisp, it's high definition. We can do 3D support as well. And also monitor offers support functions, so we can do those, certainly at Ultrabooks and tablets which support that, or actually through there. And some very computing. So we've come a long way, so I'm not sure whether you want benchmarks and that, but basically in the past people said that Intel graphics built into their processor was good, but it wasn't very good for doing high definition work such as CAD/CAM stuff or playing games or doing 3D games and that. We've added a lot more technology, we built in, we shrunk things down, and a lot more graphics computing power into our chipset now. So now you get twice the performance in 3D games, which makes it a very credible player. So you've got to spend an extra £140–150 on your system, adding in a third-party graphics power, which adds cost, it adds power consumption, and also makes more noise and more quality as well. So we're now in a space now where our graphics are as good as a £160 external car, which is pretty much covers 80% of the marketplace out there. So some people need a high definition ones to do their engineering work, colleges, universities, what have you, and others will be extreme gaming they do. So we're really seeing on there. Ivy Bridge. Ivy Bridge was made of the third generation of Intel core processors. This is Haswell. Haswell is on these beautiful devices. Yep, so better, faster, more, less power, pretty much. And then power efficiency, as mentioned that, but basically you can get up to 9 hours computing in an Ultrabook or in a tablet. You can also get 10 days battery life if you put it in standby mode. And then it's connected standby, that's the way you produce Microsoft's thing when you shut things down effectively and it's off. But it will continue to go every now and then to the server, to your wireless internet, to update things like your emails, anything you normally have to power up and check your latest Twitter, tweets, stuff like that, your social media and that. You haven't got to go there and do it, it does it automatically. It looks like it was neat. The screen doesn't come on, it just goes there every half an hour, every 2 hours, whatever you have to do, and you have to go and update yourself from the internet. So the beauty of that is, this morning I finished quite late last night at work. I came home, I grabbed that this morning, jumped in the car and come up here. But normally what I have to do in this one basically is just to sync in with the point first of all, power it up, get to my home access point, do a quick update on my outlet. It took about 5–10 minutes or so from start to finish and putting the bag. If I have that connected standby, or Intel's version called Smart Connect, it'll do it for you. Most of the phone, you don't have to go and press a button on your phone to go and get the link. It just goes forward automatically. Anyway, so that latest technology will give you 10 hours, 10 days, you shut your laptop down, and it'll be like that, perfectly okay with that battery for days or 10 days. Right, so what else do we have? Perceptual computing, making computing more human. I saw some of the artists who liked computers early on, people looking earlier on. It's not great to give people who actually like computers and have them because it makes it new, basically. But making things more human. So we have it on up here. This is showing touch rather than going to a computer keyboard, the way they get frustrated. You can use touch, you can go up to your computer, there's a camera in there, it doesn't work on this system, so it's a 2-year-old system. You can basically go and do that, make gestures, that sort of thing, you can go and get it for you. You use one big display like this rather than press a button or go to that keyboard. I can just go like that, the camera will pick it up, we can just display that for you. It's a nice little thing, which sounds like science fiction, but if you think you're actually in for example, you don't want to touch anything, bacteria, various things you can. You can do that for a thing which we have and put over your patient's x-rays, whatever you want to do with that, you can touch it. Voice control, so rather than say X4L, I can type on that, rather than press a button, I just say X4L or some predefined word that will do it for me. So you bring up the data of the customer ABC, for example, and it recognises my speech, and it will do it. We've had speech recognition around for 10 years, and I think when it first started it was very good at this. Now with Intel's technology on it, we're working very closely with companies that make speech recognition to be able to enhance the sort of things that they need to do to recognise speech, be able to make it so much more reliable, so that other parts of the brain how much you train for things. So occasionally you might get a word that doesn't understand, but generally it's really useful. On the left-hand side there in Shanghai, basically then what it is, like you say, power on a computer is basically shut down the things you're not using at any one time, reduces screen brightness and things like that. Screens do go to sort of standby mode after 5 minutes or 15 minutes, whatever you said before. But what that on the left-hand side is showing is basically the camera that looks for your eye, recognises your eye. So as you look away from it, you start talking to your colleague, it will see you're not even looking at it anymore, and it'll switch the screen off and go to the standby mode. As soon as you turn back, it recognises it in a second, it comes back and you just go and type it away. So it's a way of actually, through these technologies going together to help make life easier for you. You might be doing that, you wouldn't be getting a half day's worth of computing out of the computer. And what else have we got here? Bunch of form factors on the right hand side here, which will all support that crisscross things. Well, there's a bunch of thing here. What range of new technology for an hour and for the morning, stuff like that. What I won't bother doing is talk about all the technologies here. If you want to really find out more about those, Intel.com, technologies, I'll tell you all about them. So what else do we have? What was that prize? Who's heard of the mid-unit computing? No. Good, one. He works in. Okay, two. He works in. So, new desktops. Big one of the things, recently really big back in the old days. It's got people here. The first IBM PC came out and then packaged grey. People like that. You wouldn't want to take it around with you very far. You certainly couldn't mount it behind a monitor before you pull the wall off the wall. So, without developing our technologies, we have a lot of intellectual property, we have lots of things we can do. It's having creativity to do something with them. So, in developing some of the great low power form factors for the tablets and for the Delta books with a long battery life, we have this very, very low power consumption for a very low heat dissipation processor. So, we tried to think, what else can we do with it? So, what we had is a video that showed you. Big box and we put the radar and shrunk it down. Well, that's the creative agency's interpretation of what we really did. Video, I've got the video off of our download site, which you want the audience will hear. There's a lot of technical speaking there. But basically what we've done is taken the old-fashioned big IBM PC or the current small derivatives of these desktop power systems and shrunk it into a very, very, very small form factor which you can do things with. forget to